Hello everyone and welcome to another video, and tell me, have you ever heard something like... So yeah, then all we have to do is just calculate the 69-dimensional function and, well, then you can really render the object. It's pretty complicated, so I won't get into the exact detail. Yeah, so really often on the internet you can hear about how to solve a 10-dimensional function or how to calculate a 69-dimensional cube, and so I'm here to ruin the fun for everyone and tell you that this is BS. Kind of. But why is that? Well, it's because of math and computer science. Oh, 89% of people already clicked on this video. And so today we will learn why dimensions aren't actually that complicated. And so we should start with a number line.
Now, a number line is surprisingly a line with numbers, or more precisely, it is made from numbers. You see, the concept is actually really simple. In the middle you have the origin, and then any point on this line basically represents a value. -4 would be over here, 1 would be over here, and 2.5 would be over here.
And so yes, that is a number line, and it is actually really boring. And when a mathematician and a C programmer tells you that something is boring, that means, yeah, then it is probably boring.
But being boring doesn't mean not being useful.
But why is that useful? Well, it's because when we have a number line, we can use the numbers from it to describe things in real life. For example, number of subscribers that this channel has. So now we can put a dot right where the number of subscribers lies on this line. That's pretty neat, but it's really useless at this point. That's why we can add another line. If we rotate this by 90 degrees, add another line, then we can say that this second line would represent the date. Just the date. So now what we can do is we can move the dot to the today's date and to 341, because that's the number of subscribers that this channel currently has. This on its own is pretty useless. I mean, every point on this plane represents a different date and a different number of subscribers, but yeah, it's not that interesting. It's not that interesting unless you are a math nerd like me. The fact that you can turn this into a graph, because you see, if you color in every single dot that represents the number of subscribers that actually happened on a given date, you get this, which is a graph. And yes, that's how graphs actually work, because you see, if you have something, for example, like f of x is equal to 2x, then you color in every single point where the height is equal to 2 lengths. There we go, that's how graphs works. We got that out of the way. Now there might be one question, floating around. How is this related to dimensions? I mean, come on, that's what this video is about, right? It's literally called dimensions. I mean, what's up there? Well, you see, what's up there is tape. Let's imagine we have a tape. That can be anything, really, but we have this tape. And now we say that we want to reflect its position horizontally on a number line. So, for example, this would be a 2, this would be a 0, this would be -2. Pretty simple, and that's how we can use a number line. But now let's say we want to reflect its position horizontally and its temperature. What we can do is we can leave this first line intact and add a second line in the second dimension that would tell us what's the temperature of this tape. It would look something like this. Now, every single point on this plane reflects a different position of the tape and its different temperature. So, for example, right now the tape is in the middle, which means it should be in the middle, and its temperature would be around here. So that's the point of the tape right now. If we move it to the left, the points move to the left. If we cool it down, the point moves down. That's pretty simple. Alright, but now let's say that we want to reflect the position of this tape, not only horizontally, but also vertically. Of course, we still want to keep track of temperature, which means we need to add another dimension. So now we have 3 dimensions. 2 of them describe the position of the tape, and one of them describes the temperature of the tape. And I'm pretty certain you can see where this is going, because next question is obvious. What if you want to describe the position of the tape in 3 dimensions? Well, then what we would need is basically 3 dimensions for the position and 1 for the temperature. And yes, as weird as it may seem, that's exactly why this many dimensions are a thing. Yeah, I'll explain it again with a different thing, because I get that this might be a bit convoluted, but that's just how it works. When you have 4 numbers, you can either say that those are just 4 numbers, or you can say that it's a point in 4 dimensions, and both would be technically correct. But why is that?
Well, it's because of function graphing actually. If you have ever studied mathematics, then you are probably used to the idea that you can graph a function. So you can take all the inputs and basically show all the corresponding outputs. But it's a bit tricky, because you see, it's actually really simple to calculate how many dimensions you need in order to graph that function. It is the number of inputs plus the number of outputs. So for example, if your function has 1 input, 1 output, that requires 2 dimensions. If your function, for example, has 2 inputs and 1 output, that requires 3 dimensions. And yes, whilst it was fine for a really long time, at some point humans created computers. Now, I'm not saying that computers complicated everything, because that's not true, but especially in computer science and informatics and programming, having functions that take in a lot of things as inputs and output a lot of outputs, that's kind of standard. So in order to graph some really standard programming functions, you would need 20, 30, or maybe 40 dimensions. And it's nothing crazy, it's just how it is.
But one more thing, because you see, you may ask me at this point, why? The straight up why? Because yeah, sometimes scientists say stuff like, oh, we have to calculate something in 30 dimensions or whatever, but it's not really an everyday thing. Well, yeah, it's not an everyday thing, I'll give you that, but it happens more often than it should. And that's unfortunately, once again, because of machine learning. Yeah, I just can't get away from machine learning videos, can I? Oh well, anyway.
Now here I wanted to explain why in machine learning you often hear about these crazy functions, but then I realized in order to do that I would need to basically explain why calculus is important in machine learning. So instead I'll just do this. Here's the basic idea. When you have, if this is a node tree, this is a machine learning node tree, and you should be actually able to read it if you have watched my machine learning equals math video and other 2 videos from the series. And here's the basic idea. Those are the inputs, those are the outputs of the machine learning function, which already means that this is an 8-dimensional function if you want to graph it. But here's the problem. When you are trying to teach the machine learning function something, you are not actually working with these inputs and these outputs. It works a bit differently. Basically what you do is you take all of these weights, all of these lines, and you treat them as inputs in a new function. And you have to find the gradient of this function, which in the simplest terms, if you were to graph a normal function, which could look something like this, I guess, the gradient would be the slope. That's why you are looking for something that could be really easily explained graphically, right? When you have an actual graph. That's the slope. That's the thing you're looking for. That's the thing. You want to go down or up. That depends what kind of machine learning thing you're doing. But you want to go up or down this slope, and you have to find this slope. The problem is when you have this many inputs, you can't really draw it in 2 dimensions, and you need crazy numbers. Like when I was making a machine learning function, this just gradient descent. So then it descends, so then I guess you're going down. This gradient descent was working with a 40,302, if I'm not mistaken, 40,000 something dimensional function. And it actually was kind of solving a function, a kind of 40-dimensional function. So yeah, I get that this explains nothing, but I just had to put something in here because, you know, I just can't make this build up, but I know it sounds complicated, but that's only because I genuinely don't have the time to explain it right now. Maybe in 2 weeks I'll make a video which will explain it correctly. So for now, that's the explanation you get. You basically, it's because of machine learning. That's the reason. I'm so bad at my job.
So yeah, if you see something on the internet that seems way more complicated than it should be, then probably means that, well, it is way more complicated than it should be, and there is a simpler way to explain it. And that's why I think most of the sciencey things on YouTube are important, because you see, science is not that hard. Usually the only problem is that people who talk about science are not that good at communicating it to people who don't know science, and that's where all the problems happen. Which brings me to my sponsor. No, me. I mean, listen, I have 341 subscribers, okay? Like, this joke is still funny. Maybe one day it won't be. Hopefully. So yeah, my videos don't have a budget. That's not that much of a secret, and you know, it might be, you know, it might be getting a tiny bit more difficult to make them with every single week that passes, because I have a Patreon where you can go and, you know, get some sweet tiers with sweet rewards for relatively sweet prices. Now, if you are not the, you know, Patreon kind of guy, then may I suggest my Discord, where you can go and, you know, talk with me. I'm not lonely. Or maybe if you don't care about any of these, then may I suggest a slice of pie. Link is in the description. Make it .wt/charity/ where you can go and donate to DBS Alliance, and in return get a slice of pie for yourself. This slice of pie. Really sweet. So yeah, those are all the announcements I had for this video. I'll just go and edit the rest. So thank you all for watching, and have a great day. Bye.